Hi everyone, my name is Hussein from EJ Academy, and in this video I'm going to show you how you can use row reduction method to solve system of linear equations. In this video specifically I go over solving system of two linear equations using a row reduction method, and in the next video I will show you how you can use row reduction method to solve system of three linear equations. So when you have a system of two linear equations, each equation represents a line in a 2D space, and the answer of this system of linear equations is basically the point of intersection of these two lines. There are three possibilities when you solve a system of two linear equations. The first one is when the two lines are parallel and they have no intersection. In that case, there is no solution for the system of linear equation. In the second case, you have two lines that intersect at a single point. So in that case, your system of linear equation has only one solution. And in the third case, you have two lines that are overlaid, and in that case you have infinite number of solutions. The first case is called inconsistent system of linear equations, and the second and third case are called consistent system of linear equation. When the system of equation has only one solution, it is called independent system of equation. But when it has infinite number of solutions, it is called dependent system of equations. So the methods used to solve system of linear equations are substitution, elimination, and row reduction. In this video, we are only going to talk about row reduction method. For the row reduction, you start with equation form and transform it to a matrix form. Then you use basic row operations to transform the original matrix form to an echelon matrix form, and then from there you can get the solution of the system of equations. Now let's take a look at some examples. This is our first example. The first equation is 4x minus 5y equals negative 17, and the second equation is 6x plus 13y equals 159. This is the equation form, and we need to change it to matrix form. So the matrix would be a 2 by 3 matrix. On the first row we have 4, negative 5, and negative 17. On the second row we have 6, 13, and 159. Then we need to transform it to an echelon matrix. So the echelon matrix would be something like this. We're going to have 1 here, 0 and a number on the first row, and the second row we're going to have 0, 1, and another number. Let's call it b. This transformation will be done using basic row operations. These operations are swapping, scaling, and pivoting. I have explained echelon matrices and basic row operations in separate videos. If you're not familiar with these topics, you can check out those videos. Basic row operations should be done in a specific order to avoid undoing your progress. So in this example, we start with 6, transform it to 0. So this would be your step 1. And then negative 5 will be transformed to 0. So this is a step 2. And then 4 will be transformed to 1. This is step 3. And finally we transform 13 to 1. And this is our step 4. Let's begin with the step 1. I'm going to copy the matrix here. 4, negative 5, negative 17, 6, 13, 159. In this step, the goal is to transform the 6 to 0. So this is done by replacing the second row where the second row minus 6 fourths times the first row, and the first row remains unchanged. You may ask, where did I get negative 6 fourths multiplier? I got that by multiplying number 6 here by negative of the reciprocal of the number above it. So if I go ahead and apply this operation on the first and second row, I would get 4, negative 5, negative 17 on the first row, and on the second row I would get 6 minus 6 fourths times 4, 13 minus 6 fourths times negative 5, 159 minus 6 fourths times negative 17. If I simplify this matrix, I would get 4, negative 5, negative 17 on the first row. On the second row, the first entry would be 0. The second entry, here we have 13 times 4 minus 6 times negative 5 divided by 4. The result would be 41 over 2. And the last entry, we have 159 times 4 minus 6 times negative 17 divided by 4. And the result would be 369 divided by 2. So here in this step, we applied this pivot operation on the second row and we transformed this number 6 here to 0. Let's move on to step 2. I'm going to copy the matrix that we obtained in the previous step here. 4, negative 5, negative 17, 0, 41 over 2, 369 over 2. In this step, the goal is to transform negative 5 to 0. This can be done by replacing the first row with the first row plus 10 over 41 times the second row. And the second row remains unchanged. To get this 10 over 41 multiplier, you need to multiply this number negative 5 here by negative of the reciprocal of the number below it. I'll go ahead and apply this operation on the first row and second row. On the first row, we have 4, negative 5, plus 10 over 41 times 41 divided by 2, and negative 17 plus 10 over 41 times 369 divided by 2. On the second row, we have 0, 41 divided by 2, 369 divided by 2. I'll go ahead and simplify this matrix. So on the first row, we have 4. For the second entry, let's simplify this expression. 10 divided by 2 is 5. 41 and 41 cancel out. And the second entry would be 0. For the third entry, let's simplify this expression here. 10 divided by 2 is 5. And then we have negative 17 times 41 plus 5 times 369. And the whole expression divided by 41. So if we simplify that, we'd get 28. On the second row, we have 0, 41 divided by 2, 369 divided by 2. We apply this pivot operation on the first row and we transform this minus 5 to 0. Let's move on to step 3. I'm going to copy the matrix again here. 4, 0, 28, 0, 41 divided by 2, 369 divided by 2. In step 3, my goal is to transform this 4 to 1. What I need to do is divide the first row by 4. In fact, I can go ahead and implement step 4 here simultaneously with step 3. In step 4, the goal is to transform this 41 over 2, this entry here, to 1. What I need to do is to multiply the second row by the reciprocal of this number. So 2 over 41 times the second row. If I apply these operations on the first and second row, I would get 1/4 times 4, 0, 1/4 times 28. On the second row, we would have 0, 2 over 41 times 41 divided by 2. 2 over 41 times 369 divided by 2. If you simplify the matrix above, you would get 1, 0, 7, 0, 1, and 9. This matrix here is an echelon matrix. We need to transform this matrix to an equation form. So the equation form would be x equals 7, because the multiplier of x is 1 and the multiplier of y is 0. And on the second row, the multiplier of x is 0 and the multiplier of y is 1. So y equals 9. And this is the answer of the system of equation. In the second example, we have 4x minus 5y equals negative 17 and 12x minus 15y equals negative 10. This is the equation form. And as we did in the previous example, we need to change it to matrix form. So the matrix form would be a 2 by 3 matrix. On the first row, we have 4, negative 5, and negative 17. On the second row, we have 12, negative 15, and negative 10. Next step is to transform this original matrix form to an echelon matrix form. Similar to the previous example, we start with this entry here, we transform it to 0. So this is our step 1. And then next entry would be negative 5, we transform it to 0. So this is our step 2. Next step is to transform 4 to 1. Step 3. And finally, we transform negative 15 to 1. So this is our step 4. Let's begin with the step 1. I'm going to copy the matrix here. 4, negative 5, negative 17, 12, negative 15, negative 10. So the goal here is to transform this 12 to 0. To do that, I can replace the second row with the second row minus 3 times the first row.
Negative.
3 comes from multiplying this number 12 here by the negative of the reciprocal of the number above it. What I'm going to do here, I'm going to also implement a step 2 simultaneously with the step 1. So we have also step 2 here, and in a step 2 the goal was to transform negative 5 to 0. To do that, we replace the first row with the first row minus 1/3 times the second row.
Negative.
1/3 multiplier comes from multiplying this negative 5 here by the negative of the reciprocal of the number below it. I'll go ahead and implement this operation on the first row and second row. On the first row, we have 4 minus 1/3 times 12, negative 5 minus 1/3 times negative 15, and negative 17 minus 1/3 times negative 10. On the second row, we have 12 minus 3 times 4, negative 15, minus 3 times negative 5, and the negative 10 minus 3 times negative 17. Let's go ahead and simplify this matrix. On the first row, we would have 0, 0,
Negative.
41 divided by 3. And on the second row, we would have 0, 0, and 41. Because these two elements here and here are 0, we don't need to implement a step 3 and a step 4. And we just need to transform this matrix to an equation form. And the equation form would be 0 equal
Negative.
41 divided by 3. And the reason is that the multiplier of x is 0 and the multiplier of y is 0 on the first row. And on the second row also is the same. The multiplier of x is 0 and the multiplier of y is 0. So on the second row, we also have 0 equal 41. And as you can see, this is an impossible answer. And when you get impossible answer, it means that there is no solution. For better visualization, let's draw these two lines. First line was, let's call it line A, 4x minus 5y equal negative 17. So if x equals 0, y would be 17 divided by 5. If y equals 0, x would be negative 17 divided by 4. The other line, let's call it line B. So it was 12x minus 15y equals negative 10. So when x equals 0, y would be 10 divided by 15. If we simplify that, we would get 2/3. When y equals 0, x would be negative 10 divided by 12. And if we simplify that, we would get negative 5/6. Let's draw these two lines. So line A, we have x equals 0, y equal 17/5. Let's say it's this point here. When y equals 0, x equals negative 17/4. Let's say this is the other point. And then let's connect these 2 points. For the other line at x equals 0, y equals 2/3. This is one point. The other point is at y equals 0, x equals minus 5/6. So this is the other point. So as you can see, these two lines are parallel and they don't have any intersection. That's why when we solve this system of equations, we got no solutions at the end. For our last example, we have 4x minus 5y equals negative 17 and 12x minus 15y equals negative 51. This is the equation form. And the first step is to change it to matrix form. So the matrix would be a 2 by 3 matrix. And on the first row, we have 4, negative 5, and negative 17. And on the second row, we have 12, negative 15, and negative 51. The next step is to transform this original matrix form to an echelon matrix form. First, we transform this 12 to 0. This is step 1. Next, we transform negative 5 to 0. This is step 2. Then 4 will be transformed to 1. This is step 3. And finally, we transform negative 15 to 1. This is our step 4. Let's begin with step 1 and step 2. We're going to implement these two steps simultaneously. I'm going to copy the matrix here. 4, negative 5, and negative 17 on the first row, 12, negative 15, and negative 51 on the second row. So in the first step, the goal is to transform this 12 to 0. So we do that by replacing the second row with R2 minus 3R1. And in step 2, the goal is to transform negative 5 to 0. And we do that by replacing the first row with the first row minus 1/3 of the second row. If we go ahead and implement these operations on the first row and second row, we would get 4 minus 1/3 times 12, negative 5 minus 1/3 times negative 15, and negative 17 minus 1/3 times negative 51. On the second row, we would have 12 minus 3 times 4, negative 15 minus 3 times negative 5, negative 51 minus 3 times negative 17. If we go ahead and simplify this matrix above, we would get 0, 0, and 0 on the first row, 0 and 0 and 0 on the second row. As you can see, similar to the previous example, since we have 0 and 0 here, we don't need to implement a step 3 and a step 4, and basically we just need to transform this to the equation form. If we do that, we get 0 equals 0 because x multiplier is 0 and y multiplier is 0 on the first row, and on the second row is the same, x multiplier is 0 and y multiplier is 0. As a result, we have 0 equals 0 for the second row. So this is a trivial answer, and as a result you have infinite solutions. This case happened when the two lines are overlaid on top of each other. If we rewrite the equation, you see that this is the case here. So one of the line, let's call it line A, was 4x minus 5y equals negative 17, and the other line, let's call it line B, was 12x minus 15y equals negative 51. We can divide these multiplies by 3, and we would get 4x minus 5y equals negative 17, and this is exactly the same as the equation that we have for line A, and this shows that the two lines, line A and line B, are overlaid, and that's why we got infinite solution, because these two lines have infinite number of intersections. This concludes the first part of this video, and in the next video we're going to go over solving a system of three linear equations using row reduction method. If you have any questions, leave them in the comment section below this video and I will get back to you as soon as possible. If this video helped you in any way, please hit the like button and subscribe if you enjoy our content and would like to see more.